Welcome to one more video on differential equations, and this is meant to be an introduction to the concepts of ordinary differential equations, and we want to present here basic concepts related to ordinary differential equations. So we substitute just to ODE. That's the shortcut for ordinary differential equations. So of course the first and most important question is what ODEs are. An ordinary differential equation is any equation containing the derivatives of any one variable function. There are also PDEs, so partial differential equations. They are containing partial derivatives. We will not go into that in this section. So when we have a function y which maps the set of real numbers into the set of real numbers, and we have some relation, that is some equation that contains some derivatives like y prime equals 1. This is an ODE. Or y prime plus xy plus 3 equals 0. This is also an ODE. Why? Because it contains derivatives of, so these are the derivatives. So any equation containing the any order derivatives or any combination of derivatives is an ODE. For example, we have a second derivative of y plus 2, y prime plus 3xy minus 7 equals 0. This is also an ODE, and it contains second and first derivative of some function. Goal is to find y either implicitly or explicitly. So that is how we solve ordinary differential equation. Of course, the solution is always related to some interval. So I will just make here like what is a solution. So to solve ODE means to find any function or all functions y of t which satisfies the given ODE on the largest possible interval. Let's call that alpha beta. So not only that we have to find a function, but also we have to take care, so means to find all functions that satisfy all functions that satisfy the given ODE and on the largest possible interval. So we need also to specify for the solution in general case on which interval is that happening? Okay, so that's an important concept here. The concept of the solution, of course, that's the central concept in this theory. Okay, so that's regarding the solution. So we know what ODE is. So that is any equation that contains derivatives of the function, and we know now what solution is. We want also to know what is the order of ODE. That is the order of ODE is the highest derivative that appears in the equation. For example, y prime equals 3 is first order ODE because the highest derivative appearing is the first derivative. Y prime plus y equals 3 is also first order derivative, first order ODE. Y to the third order plus y equals 4 is third order ODE. And this is now clear what the order of ODE is, so we can highlight that as well. So order of ODE. Order of ODE. Next concept is the concept of initial conditions. And we will see what that is. Initial condition or initial conditions are, that is the set of conditions on the solution allowing to determine the precisely one required solution among all other solutions. They are of the form y of x0 equals y0 and or y to the power k x0 equals y let's say k, for k going from 1 to n for nth order ODE. The number of initial conditions, so ICs, IC, depends upon the order of the ODE. So that depends on the order of ODE. So we know now what is what initial conditions are, what a solution is, and what is the next concept is initial value problem, or IVP. So initial value problem, IVP. Initial value problem is basically ODE together with the set of appropriate number of initial conditions. Here is a typical, like one example of how an initial value problem looks like. So basically we will have one ODE, let's say the second derivative, and then we have and y prime of 4 equals minus 21 over 5. Now this all together, so the conditions on the solution together with the ODE represent the initial value problem. So this is initial value problem, IVP. Okay. Also, we have the concept of explicit and implicit solution. So, explicit and implicit solution. An explicit solution is so explicit. This comes from explicit and implicit functions. Explicit solution is of the form y equals y of x or y equals y of t. Okay, and an implicit solution is a solution which is given again as a relation, so of with the variable. For example, that can be like f of y and x equals 0. So this is an implicit solution of some ODE, the form of the solution. Okay. So we know what explicit and implicit solutions now are. So it comes just to the form of the solution itself. What initial value problem is, that is ordinary differential equation together with initial conditions. I have misspelled here. So it is one. Initial conditions. Okay, and initial conditions are here. They go to -1. What is order of ODE? That's important concept. What is a solution and what ODE is. Okay, so what ODE, ordinary differential equation, is. So I suggest you make notes of these concepts and have them before you start solving problems on differential equations. Thank you.